Our question here to use trapezium rule says that use the trapezium rule with 7 ordinates to estimate the integral of 1 out of 1 plus x from 0 to 3 with respect to x, and correct this approximate integral to 3 decimal places. So what do we do? First of all, we have to look for sub-intervals, the number of sub-intervals. So n is equal to number of sub-intervals. And we know h is equal to sub-interval width. So the width of each sub-interval is h. So what do we do? I'm going to use this formula. H is equal to b minus a out of a, whereby b is the upper limit, a is the lower limit, n is the number of sub-intervals. But the number of sub-intervals will always equal to the ordinates less 1, or the ordinates minus 1. And this is going to be 3 minus 0, because the upper limit is 3, the lower limit is 0, divided by n which is 7 minus 1. And this is going to be, in this formula here, b minus a out of n equal to h is what we always use to calculate for the sub-interval width. And the b minus a are always provided in the limits of the integral. So whereby a is the lower limit, b is the upper limit, and n is the the number of sub-intervals. So according to our question here, we are integrating from 0 to 3 for 1 out of 1 plus x with respect to x, and we are required to calculate for h. Therefore, our b is 3, our a is 0, then n is always going to be, if they talk about ordinates, if they say use the trapezium rule with 7 ordinates, they are meaning 7 minus 1 sub-intervals. So you will get 6 sub-intervals for this case. Now, if they tell you that use the trapezium rule with 6 sub-intervals to estimate the integral from 0 to 3, 1 out of 1 plus x with respect to x, please, you don't need to subtract that 1. You will use that value the way it is. So you will have b minus a divided by n. So that n is what has been provided as the number of sub-intervals. But if they say ordinates, you have to subtract 1 for you to get this n. Okay, so let's proceed and get the answer here. So here, this is a half, that is a half, and therefore I'm going to get 0.5. So this is 0.5. Now, I know that the trapezium rule formula says that integral from a to b f of x with respect to x is equal to h out of 2. Actually, is approximately not equal to, because this is not an exact integral but an approximate integral. So never use equal signs, but use approximately equal signs. So into y0 plus yn plus 2 into y1 plus y2 plus dash dash plus yn minus 1. And you close the bigger brackets. So what does that mean? It means my y0 will be f of x0. But where is x0? We have to go and draw the table that is going to do that, that is going to give us those values. So we need to get a table that has x values and the y values, or the f of x values. So since we are starting from 0, okay, we will start from 0. Then we said that the sub-interval width is 0.5, as we had earlier on calculated. So we'll go to 0.5 then to 0.5, the difference. So we keep on adding 0.5 until we reach 3. So here we are going to add 1.0, 1.5, 2.0, 2.5, and 3.0. There we shall have finished. And then we start substituting in this. This is supposed to be y equal to 1 out of 1 plus x. That is our what? Our f of x. This is our f. And therefore, at x is equal to 0. So at x is equal to 0, f of x is equal to 0. It's going to be 1 out of 1 plus 0, and that is 1. So we put here 1. What about if it is 0.5? So if it is if x is equal to 0.5, f of 0.5 is going to be 1 out of 1 plus 0.5. This is 1 out of 1.5. And my answer here is 0.6667. Okay? So what if I have 1? So f of 1 is equal to 1 out of 1 plus 1, and which is equal to 0.5, because this is a half. So that would tell you that what I write down there is going to be 0. So I put 0.5 here. What if I have x is equal to 1.5? So x is equal to 1.5, that is 1 divided by 2.5, and that is 0.4. Then what if x is equal to 2? So I will have 1 divided by 1 plus 3, okay? And that will be, no, it is 1 divided by 1 plus 2, that is 1 out of 3, and that is always 0.333 recurring. So 1 divided by 1 plus 2.5, that is 1 divided by 3.5, and I'm getting 0.2857. What if I have 1 divided by 1 plus 3, that is 1 divided by 4, and that is 0.25. So what do I do with these figures? I already know that this one is y naught. This is y naught. This is y1. This is y2. This is y3. This is y4. This is y5. And that is y6. So, which is the same as yn, because that is the last one. So that means when I come here, okay, what I'm going to do is to substitute in those values. So that integral will approximately equal to h out of 2, h is 0.5 divided by 2, then y naught is 1, yn is 0.25. Then 2 into, now I have, first of all, the y1 is 0.667, 0.5, 0.4, 0.33, up to 0.2857. So I put those values, 0.667 plus 0. 0.5, 0.4 plus 0.333 plus 0.2857. Then I close that. So this value, if I carry out this evaluation, I'll have 0.25 times 5.6214, and this gives me 1.40535. And if I want to put it in 3 decimal places as requested or as required, then integral of 1 out of 1 plus x with respect to x from 0 to 3 will approximately equal to 1.405. This is to 3 decimal places, and that will be the approximate integral of 1 out of 1 plus x with respect to x from 0 to 3. If we want to try that, please you can put it in the calculator and get the exact value. But we can also do it because we know integral of 1 out of 1 plus x with respect to x from 0 to 3 is the same as natural logarithm. The same as natural logarithm of 1 plus x. So from 0 to 3, we can now find that this is going to be ln of 4 minus ln of 1. So if I put it on my calculator, natural logarithm of 4 minus natural logarithm of 1, okay, what do I get? I'm getting 1.386. This is 3 decimal places. So what is the error here? The error will be the exact one, 1.386 minus 1.405. Okay, if I wanted the percentage error, so I will divide it by 1.386 times 100. So this will be 1.386 minus 1.405 divided by 1.386. So times 100, I'm getting negative 1.37% as the error. So this is very small and it can be neglected, but you can also, like here, if you wanted the answer in 1 decimal place, then I would gladly say this is approximately 1.4 and the other one would be 1.4 also. So that would be an error due to rounding off, but then it would be bringing you closer to the result that we want. So as you have already seen, the trapezium rule or any other numerical integration gives you an approximate value of the integral. It does not give you the exact one.